Sound design. All right, so the first thing I did here in Smart is to just measure my microphone cables, just double check that everybody is matching polarity and everything looks okay. I did notice that this old cable that I've had for over 10 years looks a slightly tiny bit different. Just kind of interesting how it can change a tiny bit with age. But otherwise, those all look good. The next thing I want to do is go through all of my settings one by one. So sample rate, 96K. There we go. Coherence. Show coherence, squared coherence, and we'll set this at 95. Okay. We did that. Averaging type. Complex. Okay. Averages. Infinity. Okay. Smoothing. Okay. Live IR window. Okay. All right, the next thing I want to do is check my hardware settings. And I don't have any huge guidelines here. The main thing is that I want to choose the settings that someone else or my future self will be able to recreate. Beyond that, I just recommend kind of manufacturer defaults. So let's go take a look at this speaker that I have set up here. Got this set to main, this input here set to line. And unfortunately, there's no detent on this little volume knob here, but you can, it says +4 dB up here at the top. So I'm assuming that that's standard default +4 dBu line level. And it's too bad that it has a range, not like a specific position, but I just tried to get it as close to like 12 o'clock right there as possible. Next thing I want to do is work on the placement. So I'm using a common estimation here, which is 3 times the baffle diagonal. So I could have looked at the spec sheet, but I forgot to do that. So I'm just out here and I just take a measurement here to across the diagonal of the speaker, and the rangefinder is going to have a hard time because it's bright out here. And it's 2.46, but I'll just go ahead and up that to 2.5. 2.5 times 3 is 7.5. So I just want to make sure that I'm at least 7.5 feet away. And this is definitely 7.5 feet away. I think this is probably more like 14. Yeah. So 14 feet away. So I'll start pretty far away and then see if I need to get closer. Okay, so I know we're going to do a ground plane measurement, and now we're going to do the input calibration. So over here in Smart, I've already got a sine tone running. You want to make sure that this is at 0, this is at -12, and this is at 1K. And then I've got some giant meters I can open up. Pretty cool. So you can see that I've already set this one. So I have just a loop on my audio interface. Maybe I can get a picture of that later. Just a direct loop from output to input on my Octacapture, and then I just turned this fader up and down until I found this position, which is -12. Okay, so I can show you that if I go up, it'll be a little bit too high until the yellow, and so this seems just about right. The next thing that I did was to turn on my microphone calibrator here. And I know a lot of people's, I think the max is 114, which is what I would use. But in this case, I'm using 110. So I'll go ahead and turn that on. I've got my microphone plugged in. And so now I've got it in the calibrator there. And so with this hand sort of holding the microphone in place, then you can see that I've already done this before, so it's already set. But what I did was just turned up this microphone preamp until I hit -12. So now I've got parity here, right? -12 dB FS on both of these input meters here. Now, the next thing I want to do is make sure that I have this speaker pointed at that microphone. So hopefully I can see this laser, because that's what I brought. Another trick is to put a mirror or a cell phone in selfie mode here on the speaker, and then see if that can see the microphone. But I'm going to see if I can see this laser. And here's how I propped it up. You see this tape roll down here. I did the microphone calibration procedure. Start the measurement. Basically, I just want to make sure that I'm getting high enough coherence here. Someone was vacuuming nearby. I'm outside. There's wind. So we'll see how this goes. I may need to get closer. So I'm changing the signal generator back to pink noise for this test. And I'm going to turn it down because it's going to come straight out of my audio interface into the speaker, so I want to make sure it's too crazy. Cool, so I'm just kind of turning this off and on real quick so I don't bother any of the neighbors before I turn it up all the way. And just noticing that, check this out, inverted polarity. It's an interesting thing about this speaker that I've noticed before. This is now why you know that I went and checked my microphone cables first, so now I wouldn't have the question of, what, is there a polarity inversion in one of the mic cables? No, it's the speaker. Oh yeah, you can see it moving around a little bit. So what I did was I turned on delay tracking, and that actually seemed to help. And it's just up here beyond 12K that I don't really have data above 95% coherence anymore. Cool, so I've got pretty much 3 of the same thing. Let's switch over to the sub. So I gotta turn off auto set delay. And I screwed up the delay, so let me go back and just use one of these delays. It was at 8.22. We're getting down to 36, so that's probably good. Now that I know that that's going to work, let me make sure that I measure this distance, because I'm going to want to log that later. 7.48 feet. So basically I'm just watching until this stops changing. Now I need to put the 615 back again because I forgot to measure it the first time. 8.83. Okay, so I have recaptured this guy. I wonder if we got closer, would this ripple go away? Or if I got farther away, would the ripple go away? So I'm going to try a couple different distances real quick, just to make sure that's not the case. So I'll try significantly closer first, 4.91 feet. The ripple did get better, but we didn't get much more data up here. So let's try one farther away as well. All right, this time at 19.04 feet. So if we stop all of these and we just match all of these, it looks like through the entire range here, potentially this purple one, the closest one, had the least amount of ripple. It looks like it had a pretty good amount of coherence, but we lost this data up here. Yeah, so I'll have to take this back home and I'll probably do a little bit more thinking on which one of these I want to use in the end. So on the way back home, I remembered that the basement is empty right now because they're remodeling, and it's pretty clear down here. The ceiling's at about 9.5 feet, and there are no real walls put up yet. So I thought I'd be able to get a much better measurement here. And as you can see, I tried 3 different distances 9, 6, and 4 feet. And I got better data here up in the very high end, which if we compare to my measurement from the alley, it's a little bit hard to see because the color is pretty much the same, but you can see I have a lot of missing data up here beyond like 12, 13K. But no matter how close I got, I could never get the same quality of data down here in the low end. So to walk you through it, this is 9 feet where I'm missing, almost half the operating range, and then 6 feet. I'm sorry, this is 4 feet where it's the best, but also interestingly more ripple up here. So the ones that are farther away, 6 and 9 feet, have better ripple, but very little data down here. So just an interesting test. I just wanted to see if it would be better to measure inside, out of the wind, and it is, but only for this tiny portion up here, which I don't care so much about anyway. Over here on this form that I have, I can fill all this stuff out. So where am I? I am, and we'll put the main in first. The brand is JBL M. Had my microphone calibrator set to 110. And I'm doing transfer function measurements. Okay, microphone distance 8.83 feet. Delay locator. Here, I'll look for where it says delay. So 9.15. External amp, no. And this is where I'll upload the files. So I recommend the native format. You don't have to export to ASCII or anything like that. And so I can just go over here, right click on this, open file location. And then when I go to add file, I can just drag this over there. Upload. Okay, I'm having trouble getting the photo off my phone right now, but that's where I would add that. And I hit submit, and then I'll submit another response so I can do the sub. 7.48 feet. So if you hit this yes on the external amp, that'll basically just take you another page where you can put in all of the information about the amp that you're using, the firmware and stuff, so make sure that stuff is documented. Upload the file. So those are all the steps that I put together for how you can start taking your own measurements of your own speaker inventory and creating a database of actionable data so that anytime you go out into the field and you're going to use those speakers, you have a reference point and you can use that to make shortcuts and work a lot faster when you get in the field. So let me know if you saw me do anything wrong or if there's anything that I can do better or faster. I'm always trying to improve my methods here. And if you try this out, please let me know how it goes for you and what results you get. Thanks.
Sound design.